going to introduce Paul Vixie, who is ISC president. He will talk about silo busting in information security, the ISC SIE approach. Thank you.
I'm not bringing slides today because I have some complicated things to explain, and I don't want to distract you by having you try to read and listen at the same time. There will be a demonstration, so I'll be using the projector about halfway through. So silo busting, in this case, refers to the relationship between people who run networks and people who sort of sell security, I guess, reputation services or threat information systems. Let's just estimate that somewhere around 1 to 2 trillion US dollars worth of market capitalization have been created in the last 20 years in what used to be called the antivirus field. In fact, I think about every 3 or 4 weeks, somewhere in the world, there's a new company that starts up with the idea of selling into that market. And perhaps they're going to sell to you an application that runs on your smartphone or your laptop. Perhaps it'll be a server-side security feed that you might connect to your mail server so that you can reject spam, or a server-side feed that you can plug into your antivirus product on your MTA so that you can, reject attachments that have bad checksums. Whatever it is, we have really created a lot of wealth. And I want to focus on that wealth for just a moment because what I noted 5 years ago when I began the work I'll be describing today is that we've created a great deal of wealth without making the problem better. Now, often if you create wealth, what you end up with as a result is a working railroad system, highway system, some new fleet of commercial ships, transatlantic cable. You pay some money, you invest some money, you build something that is useful, people use it, and the use of it then makes it valuable, and then you sell it, or you sell futures in it, or something like that. So, in other words, speaking capitalistically, when we make investments and create capital wealth, it normally corresponds to having done something. In the case of this trillion or more dollars of wealth that we've created as far as the market capitalization of Trend Micro and everybody else in the AV field, everybody who would like to sell security threat data or reputation data, the problem is as bad as it ever was. It might even be getting worse. It may be that the more we invest, the worse it gets, which is kind of the opposite of what you want. Capitalism is not helping us here. My investigation into the reasons showed that we have a structural defect. So what's happening is a new company will start up, and it'll be a couple of guys who all left some other company at the same time, or they all went to college together, shared a dorm room. And they will say, hey, I know, let's create a new security company, and for some annual fee, we will sell to large enterprise the ability for them to detect threats against their infrastructure and keep those threats on the outside. And everybody says, yeah, that's a great idea, but how do we know where the threats are? What are the ingredients? How do we build the thing that we want to sell? And the answer comes in the form of, well, let's give something away first, and maybe it'll be some kind of an online reputation service. And from the query stream to our own online system, we will learn sort of what's happening out there, because people who are running our free software or using our free service will be asking us questions, and those questions will implicitly tell us what's going on. So by data mining our own query stream, that's what I did with the original anti-spam company called MAPS, M-A-P-S. We created something called the RBL. And we got a lot of really useful information by looking at the query names. Because if you get a query to an RBL feed, it tells you immediately that somebody corresponding to that IP address, the IP address that's encoded into the DNS name, just tried to send email to somebody. And if a whole lot of people start asking you questions about the same queue name, then you know that particular IP address is trying to send email to a lot of people. Unless they're on your white list, you could just assume they're bad. And there are, of course, a whole bunch of rules that you would apply and smarter software than that, but that's generally the way network telemetry starts coming into one of these new companies. There are, of course, other things you can do. You can use public information. VeriSign for the .com zone allows anybody on the internet, if they fill out some paperwork, to download the .com zone free. And a lot of people have made a business of downloading that zone once a day, looking at the differences from yesterday to today, saying, well, those differences are the adds and drops, and all the new ones in the last 24 hours are immediately suspect because, as we know, most new domain names are crap. So that would be another example of where you get your telemetry. But neither of those is likely to make you competitive. If you want to be in the threat information business, you want to sell reputation feeds, you want to sell antivirus packages of some kind for smartphones or laptops or whatever, you need to be able to demonstrate to your customers that you have information other people don't have. Otherwise, why should they do business with you? And the usual result of that line of thinking is, okay, who do we know who runs a network, who's got maybe an Ethernet switch full of servers, and is willing to let us hang one of our servers on their switch and set us up on a span port so that we can watch traffic go by without interfering with it, but we can gather telemetry information that way. And inevitably, in what used to be called a Rolodex when I was a kid, but I guess now is called your contact list in your phone, there will be a list of people that you've done business with or gone to school with or drank with who operate such networks, and if you're the first person to call them, they might be willing to install some of your equipment in their networks so that you can gather telemetry. And that's where the real value seems to come from. It's companies who have done that well who have really risen to the top of the heap in terms of succeeding in this business and creating the larger share of that $1 trillion market capitalization that I was describing a few minutes ago. Here's the problem. You really have to be the first person to call that particular network operator. If somebody else has already got a telemetry server and is already collecting information about what's happening on that network, they're likely to tell you, look, I'm not in this business. I can't sell this. I can't turn sort of the favor you'd like me to do you into a business. I can't make this even a cost recovery case. If I tell my lawyers that I'm selling this, they will kill me, or what's worse, they will want to sell it to someone who is not you at a much higher price. So this has to be kept on the QT. We have to do this quietly. We have to make sure that nobody catches me giving data away. And that means I really can't do it for everybody who comes in the door. I'm going to do it for the first person. And again, that plays into the business model of creating all of this absolutely useless wealth. I say useless because it's not solving the problem. I don't know about you, but I am less safe on the internet now than I was 20 years ago. So that wealth is not doing me any good, other than the share I have earned myself, I suppose. Anyway, these are exclusive relationships between the places that things are happening on the network. This could be an ISP, an enterprise, a university, name server, mail server, whatever it is, and a given security company who is trying to roll that data up and turn it into something that their customers might be willing to pay for. And I want to emphasize again, if you're not doing something like that, you won't be competitive. No matter how many honeypots you set up, or how much public information you pull down, you still have to be able to do this, or you will not be seeing threats early enough to outcompete the other people who want the same customers you do. Or at least that's the perception. Now, these are what I call information silos. A silo is a tall thing, sometimes full of corn or grain or whatever, and the bottom has an absolute gravitational relationship to the top. Things flow down. They don't go sideways. And in this case, an information silo is a relationship between some network operator having telemetry, having the ability to inform or observe about what's happening on the network and some consumer, some security company who wants that data. Once we silo something, other competing companies can't get it, and the customers of those competing companies can't get it. The more information silos we build, the more stock value we create, the more of that $1 trillion we accelerate, and the less of the problem we can solve. Because anything that we've got an exclusive lock on will not be seen by enough of your competitors to protect enough of the world to do any good. In other words, the more of this stock value we create, the more we benefit the bad guys, because they can operate pretty much freely, because very few people will ever get a chance to cross-correlate what they're doing. It's as though you're in a room robbing people, and unless somebody points a flashlight right at you, that you can't be stopped. I'd prefer to turn the lights on. I would like the internet to become more safe rather than less safe someday. I would like the trend to reverse, although frankly, if it would just stop getting worse, I would treat that as a victory. Right now, the internet gets less safe every year. So in 2007, we at Internet Systems Consortium created some open source software around an open data concept. The original software is gone now. It was called NCAP for network capture. And we had to develop software because there was no standard tool set or standard network packet format for telemetry. It's not like you can take a PCAP file and play it over the network somehow. You can take a PCAP file and copy it if you stick it in a file and rsync it from server to server. That's pretty much what we all do. But that doesn't scale. So we developed some software to do this with datagrams rather than TCP streams. Datagrams are unreliable, but they are also very lightweight, and you can broadcast them. If you're on an Ethernet switch and you have data you'd like to share with everyone, you can transmit it with what used to be called the all ones address, and everyone receives that packet at the same time. If you wanted to do the same thing with TCP, you'd have to rsync to each person individually. So we liked packets, we liked datagrams, and we developed some tools for that. I developed those tools, and I say proudly that they're crap and they're all gone now. They've been replaced by better tools written by younger men. But since 2008, so for the last 3.5, 4 years, we have been operating an open data facility. We call it the Security Information Exchange. I talked about it here 2 years ago and was well received, but a lot has happened since then, and I know that a lot of you weren't here 2 years ago, so I offered to sort of say again what I said then. Please send us your data. If you operate infrastructure, whether that's a spam trap or a honeypot, DNS server, whether you've got a network telescope, whatever type of information you have, either because you operate it for the purpose of gathering security telemetry, like a honeypot, or you just have it because you operate a network, is very interesting. It's very useful to people who would like to stop crime. Do not give it to whoever you went to college with when they call you and say, could you please insert this server in your network? Because if only they have it, then the bad guys will benefit way more than he or you will benefit. We don't want to do that. We have to find a way to align our actions with the end result we'd like to obtain. So what you would do instead is find an information sharing facility somewhere, and mine is, the one at Internet Systems is at your disposal. Send the data to that facility and get them to give you some kind of feedback about who else is receiving it, who they will share it with on your behalf, and what those people are able to do with it. I'm going to show you what we do with that data, but before I get to that, I want to sort of go through a little bit more of who's sending us the data and what it is and what we do with it. That's what I call the front-end problem. Josh, welcome. Right. So let's imagine you are running a name server, recursive name server, possibly in this building, serving the wireless network, so that when a DHCP lease is handed out to somebody, it's got your name server's IP address in it. That causes your name server to receive a lot of DNS queries from laptops, smartphones, whoever's on the wireless. Anytime it gets a question that it has seen before, it is likely to be able to answer that question from its cache. It won't have to go upstream. It won't go ask VeriSign, well, where is, example.com? It won't ask the root name servers, well, where is .sg? It doesn't have to go upstream and ask anybody anything if it's already in cache. Those transactions are not interesting to me, mostly because they contain personally identifiable information. In other words, the IP address of the person who asks that question is considered PII in most countries, and I don't want to fight those battles. But that upstream traffic, if you ask that name server, if someone asks your name server something you don't know and you have to go find it, that has no PII. Those transactions, what I call your upstream or cache miss transactions, are fair game. You can share them with anybody without really having any of your lawyers or anybody responsible for your country's privacy laws raising an eyebrow. Ideally, you'll share them, again, with me or with someone like me who will make them further available. What you can do if you receive enough of this data is rebuild the entire DNS one response at a time without ever making any queries on your own behalf. This idea first came to me when Florian Weimar, as a German student, as part of his master's thesis at University of Stuttgart, did something called passive DNS logging. And his particular use case was that the .de domain for the German, as the German country code domain, had been made private, had been taken out of the public domain. You could no longer transfer it. And so he, being an engineer, very smart and very passionate, decided that he would recreate the content of the .de domain one response at a time and then make his copy of it publicly available to sort of challenge the lawmakers on this. He achieved his aim, but he also created this marvelous model that we all now call passive DNS. So we need your response data. I don't just mean for this wireless network. I mean from your houses. If you've got a name server at your house, if you're in this room, you're smart enough to be running your own name server. You are not using the one that came with the small plastic box from your DSL provider. If you are a DSL provider, if you are a university, if you are a small enterprise, and you run a name server, please consider running a passive DNS sensor. That sensor will look like a background daemon, just a server process. It hooks in the same place that TCP dump would hook in. So it just uses what we call the BPF, the Berkeley Packet Filter, to grab all of the packets related to DNS and sort of reassemble the related ones into the underlying transactions that cause those packets to be sent. And then it will uplink those, reassembled transactions to us. You could do the same thing with spam if you have a spam trap, honeypot. Whatever data you're gathering, if you're in the security business, is of great interest to other people. If you share it with us, we will share it with them. Something called darknet. I love darknet. Sometimes called a network telescope. It's hard to believe that now that IP version 4 has been fully allocated and there's not really very much left in inventory, that any part of the IPv4 address space as advertised into the global BGP tables is not full of people. But it's true. Quite a bit of it is sparsely used or even not used at all. There are some companies who were on the internet back in the early days, 25 years ago, who have large amounts of space which they advertise into the global routing table, but they don't have any customers on it. So what they receive in those advertised but unused blocks is what you could think of as cosmic background radiation. This is code red, this is Conficker, this is everybody who has got some bit of malicious software that needs to find other hosts to infect. They're constantly probing what we call the network telescopes of the world. And I've got 6 Class Bs worth, 6/16s as they are now called, worth of space from various people who have the space and aren't using it, and they'd rather share it with us than to share it with the first security company who asks them. We make it available to any security company who asks us. Now, what do I mean make available? I've mentioned all the sensors that you could be running and sending us your data, but what do we then do with it? This turns out to be controversial. You will send it to us usually in very small batches. We let you build up about 1 minute worth of traffic on your side and then use rsync. I don't like that rsync, and I don't like that 1 minute of delay, but I recognize the need for you to be able to compress it on the way to us. And if you were to send it to us packet by packet by packet, it would all be clear text, unencrypted, uncompressed. And I know that there are parts of the world where that is an expensive proposition. So we let it build up for a minute, and then you will send it to us. When we receive your batches, we uncompress them and open them and play them sort of as though they were tiny little music files. We play them on a private Ethernet switch in our facility. And anyone who has paid us a port fee to be connected to that switch is then able to see your data with about 1 minute of delay, along with everybody else's data. Now, when I say pay for the privilege, I have to say that no one has been turned away because they couldn't pay. We have plenty of just internet do-gooders who get connected because they have a public benefit use for that. We are a nonprofit company. We want to help those people. On the other hand, if you can afford it, then we will make you pay us whatever we think you can afford for that port. And we have, I think, about 40 different companies. Some of them are security companies. Some are university researchers. We have a couple of law enforcement agencies, government intelligence services. Whoever convinces us that they are going to make the world safer as a result of seeing your data gets a chance to be on our switch. Now we play, as I said, we play these as though they were music files. We pretty much spew them out at top speed and then delete them because we have no ability to, it's about half a gigabit per second of traffic. We have no capability of storing as much data as we carry. I know that some of our customers do. Jose up here in the front has been connected to our switch on and off over the years, and I'm betting he's got enough disk space to store it all, but we don't. So our job really is to be the bearer channel. We created the sensor software and formats. We encourage people to run our sensors. We collect the data, and we connect people to the switch, and then we play the data on the switch and delete it. That's our role. That's our. This is, to me, an open data play. Interestingly, we've got 2 different security companies who have come into existence since 2008 when we first opened for business, who were able to hit both first revenue and profitability using no other data than what they got from us. And to me, this is a wonderful proof of the concept that information silos are a false benefit. Right? This idea of having an exclusive relationship in order to keep your competitors from having it be the only way that you're going to make profitability is false. It's false on the face of it. What matters is how smart you are at processing the data and how good your salespeople are at telling people what you have and closing deals. So the efficiency of your organization and your engineering and marketing and sales departments are going to be much more important than what exclusive access you have. Although, on the flip side of that coin, the exclusive access you have will certainly help the bad guys. So there may not be any good that can come of it, but there certainly will be some bad. Right. Trying to. So the first thing I've asked you to do is please run a sensor. Send us the data, or if not us, send it to somebody else who was doing the same thing. The second thing is connect. Find out what it would cost you. It could be nothing if you're doing only nonprofit good work. It could be an easily affordable amount of money. Plug into our switch, get the data. The more people who process it and turn it into security intelligence, the safer the world will become. Now, thinking of the third thing you might do, some people don't want to share their data openly. They think that it is valuable and they want to sell it, but they don't want to have the problem of finding customers for it, negotiating with each customer, and figuring out how they're going to send the data to each customer. And in that case, they've come to us, and we have half a dozen of these now, and they've asked for a private channel. Every VLAN on this private Ethernet switch that I told you about is what we think of as a channel, kind of in the sense of digital satellite television. And most of them are public. We created them. We determined what the format would be for packets on that VLAN, and we are in charge of what customer gets to be in that VLAN and see the data on that channel. But you can also ask for your own. We don't charge for that. If you will only share data with people who pay you money and pay a license fee, that's fine. To us, at least, you're still sharing the data. So the fact that you're demanding payment for it does not make it less of a public benefit act for you to share it. Therefore, we will carry the data for you. We will be your distribution channel. So several of the larger spam traps who have between 50 and 100 megabits per second of spam that they are receiving want to make sure that if their direct competitors are planning to improve their anti-spam reputation feed using the same spam trap data that they themselves are collecting, they should be able to hold each other for ransom and make each other pay money, and they do. And they still use us to distribute it because it's one-stop shopping. They send us one copy, and all of their potential customers will just get access to it for nothing. They also have the option of sharing it in real time with the same set of academic or nonprofit do-gooders that we share data with. If they want to make it available free, they can. But it turns out to be a wonderful information sharing system, even if it's not fully public or not in the public domain. So I want to talk about, I want to move to how we are using some of the data on the for-profit side of my company. But before I do that, please use this moment for questions about what I call the front end, about the sensors, the formats, the rules for connecting to our switch. Help me out here. Don't make me pick on Jose. Jose, ask a question.
Under what circumstances would you disconnect it?
We have denied access to only one person in the 4 years or so that we've been doing this, and it was because they had no references. We didn't know who they were. They were from a country where I have no friends, and they could not identify anybody that we had in common who would give them the thumbs up and say, yes, this person is not a spammer. They are not some ex-KGB digital gangster. That, you know, I have to have some positive reason for connecting people. And we had only one out of the 40 or so that just couldn't meet the bar. I don't know if they were a legitimate or a non-legitimate player, but anyway, that's the second half of your question. First half, when would we disconnect? There is a contract. There are terms of service. You have to agree, among other things, not to reshare the data. You can use it for your own private purposes. You can sell products based on it, but the raw data, once it's in your hands, cannot leave your hands. And no one has yet been thrown off, disconnected, terminated. No contracts have yet been terminated, but we have had to send some warnings to a couple of people who were mixing our data in with other data that they were carrying and sort of not paying attention to where it all came from. And it was quite accidental that they were including raw data they got from us in something else that they were giving away. So they weren't even monetizing it necessarily. They were, however, leaking it. So that if the cease and desist warning had not worked, then we would certainly have pulled the plug on them. Josh, ask a question.
For those that want to, what sort of backbone connections do you guys have? What research networks?
Backbone connections. I'm trying to correctly interpret your question. The data sharing facility where this Ethernet switch is inside of an Equinix facility. In fact, we've got two of them. One is in Equinix Ashburn, and one of them is in Equinix Palo Alto, which I still think of as PAX, having been the founder there. So that is where people go if they want to plug into our switch, and we make them rent cabinet space and buy transit from other people who are in those data centers. If you are one of these nonprofit do-gooding freeloaders that I have mentioned, then we will let you install your equipment at ISC, where we have dark fiber to both 200 Paul and 529 Bryant, and we peer with 190 other networks, and we run multiple 10 gig trunks in order to make sure that if there's a problem, it won't be on our network, is I guess the rule there. That network, the Bay Area Research Network that is ISC's backbone, is also where all of the incoming data arrives. And so chances are very good that we have transit from a couple of companies who have just donated transit to us in 10 gig increments, but it is very rare for sensor data to arrive over our transit connections, because we really do have pretty bright peering. Ask your question louder.
Sorry, lack of physical access to one of those two data centers is not as much of a restriction as somebody might think.
No, lack of physical access. Go ahead. Physical access will not cause a problem. If you just can't afford to own your own equipment at all, then we will let you have a KVM on one of our Blade servers. We've got a couple of contracts where we ourselves sort of receive the data and then turn it back into batch files and rsync it to somebody, because that was the only way that they could possibly do it, and we thought their use was public benefit. Okay. I'm going to give you a demonstration now. Let me explain what this is. Let's see if it comes up. So I told you that our primary role is to build and maintain the sensor network, define the formats, we wrote the tools, we do all the outreach as far as sort of getting the data and getting more data over time. We also have the role of hearing the data. In other words, after we broadcast it on this private Ethernet switch and throw away the copy that you sent us from your sensor, we feel that we're as entitled as anyone else to hear the data that we've broadcast and then to turn it into value-added products. Value-added products for a nonprofit is a little bit controversial. You end up competing with your customers, and you end up having a complicated relationship with your tax authority, because some of your revenue is taxable and some is not. So we have multiple different corporate entities that are all tied together in a way that tries to make sense of that. Nevertheless, because no one else built this, the DNSDB, no matter how often I would ask them, please, could somebody please take the raw data and turn it into a database that questions can be asked of, it wasn't happening. And I realized that the people who were plugging in and receiving the data had existing business plans, they had existing product roadmaps and so forth, and they could not be bothered to also build the thing that was going to leverage us in some good way. And they just couldn't get the resources, or it was too darn much data. Half a gigabit of real-time UDP is tough. You could call it drinking from the fire hose, but it is more like laying under Niagara Falls with your mouth open. It's a lot of data. So we have a multi-stage filtering system that I'll describe first, and then I'm going to get to the demo using this, what's on the screen here. When you have hundreds of megabits of passive DNS data, which are the aggregate of all the cache miss traffic that was received at dozens of universities and ISPs, hundreds of name servers across the world. A lot of it will be duplicative. There's a huge amount of self-similarity. If some name is suddenly used somewhere and it's whatever, www. something or other, josenazario.com or whatever, chances are that it's about to be seen everywhere. And if you see a new thing, you can almost just set your watch. Okay, in the next few seconds, everybody else is going to get interested in that too. And that's a hard problem, because if you're about to deploy a lot of infrastructure to process this data, and most of it is duplicative, then your first task is to dedupe it, so that you're not using high cost and perhaps low performance SSDs or something with persistent media on something that is actually garbage data. So we developed our own deduper that operates in the following manner. It connects to the Ethernet switch that I've described twice. It is in 2 different VLANs. It hears the raw data at the same time as everybody else hears it. It maintains about an 80 gigabyte hash table, and it processes every inbound message. And if that inbound message has some new thing in it which causes an update to the hash table, then that inbound message is copied to the other VLAN, to the other channel. If on the other hand, that inbound message changes nothing, it's dropped on the floor. This gives us about a 20-to-1 reduction, and the input can be hundreds of thousands of packets per second, or messages per second, I should say. The output will tend to be 10, 15,000 messages per second. Now, the particular host that does this is pretty much the most expensive computer that I have bought in recent years. It has not only a great deal of memory, but the very fastest cores and the very fastest front-side bus and so forth. And every 6 months, when it becomes yesterday's technology, we replace it with something newer and faster and more expensive. And if you stand behind the rack where all of this work happens, and you run your hand along the back of all of the servers, you can tell which one this is, because it's the one that has the most heat coming out of the fans on the power supply. Nevertheless, it means everything else that wants to process this data does not have to be that expensive, because 10,000 events per second is nothing. You can do that on a laptop. Now, we have other post-processors that work the same way. They copy from some source VLAN. They maintain some kind of state. They have some kind of rules, and they will drop some things and forward others. For example, we have what we call the chaff filter. I don't know if you were aware of this, but Netflix uses DNS. It makes a DNS query from their little application, their streaming application, every time they are wondering if you have permission to watch that. So it encodes into the DNS who you are and what is the content that it's asking about, and then I suppose it does a one-way hash of some kind using a private key, and then it asks a DNS question. And so that turns out to be a big seller for them, because I can tell you that's thousands of packets per second now. But one thing you don't want to do is put that in a database, any more than you would want to put an RBL lookup in the database, or DNS tunnels. A lot of people use DNS as a tunneling protocol in order to get through some kind of a paywall in coffee shops. They want to use the wireless, but they don't want to pay for it, that kind of thing. If DNS works, they'll tunnel their other traffic over DNS. We have an extraordinary list of the patterns, the various domain names that those things are happening in. And we have a filter that reads the dedupe channel that I just described, and basically splits the flow into wheat and chaff. If you're a farmer and you're trying to deal with the crop that you are bringing in, you're going to find that you have quite a bit of weed seed that is mixed in with your wheat seed. The weed seeds are called chaff. So we actually have a chaff channel. In that case, we don't drop the chaff, we broadcast it onto a particular channel. And we have one company who came in, wanted a port, wanted to connect, wanted to get the data, and the chaff channel was the only thing they wanted. No, we don't need any of the dedupe stuff. No, we're not using spam. We don't care about darknet. Just give us the chaff. I have no idea what they're doing with it, although I could guess. But, you know, one man's garbage is another man's jewelry, I suppose. So that trick of multi-stage filtration works very nicely, and it's something that proves the point that Ethernet can be used for something other than plugging our servers and our desktops into. The broadcast that we do is obviously simulated. Ethernet has come a long way from having been a private radio spectrum inside of a well-terminated coaxial cable. So these Ethernet switches are doing quite a bit of work to simulate broadcast, right? If you send a packet with all ones and it has to put your packet into everybody's output queue, chances are that is going to be a lossy and unreliable proposition. And I will tell you that we are on our third Ethernet switch so far, and we're now evaluating what's going to be the next one, because broadcast is not something that is usually done in hardware. It's not something that the designers of Ethernet switches optimize for, but it sure does work well for us. Right. So eventually we get it down to around 10,000 per second, and we build a database out of it. I'm going to give you a demonstration of that database, but before I do, I want to point out that we're not the only one. There are other passive DNS databases in the world. I know Team Cymru has one that they use in-house. It would shock me if Arbor didn't have one they used in-house. BFK, which is the employer that Florian Weimar went to after he left university, they have one. In New Zealand, there's one called DNS Parse. There are two radical differences between us and them, between us and all of them. First, we make the raw data available, and they don't, right? So if you think you're smarter than us, you may be right. And if you think you can make a better database than we can, go to it. We will give you the same inputs we have. You can get the raw data, dedupe it yourself. You can get the dedupe data, whatever it is you want. All of our intermediate data products in the real-time front end are available. And we encourage people to prove that they are smarter than us. We want we want to be part of the rising tide that raises all boats. Second important difference between us and them is that we have a very strange business model. If you are interested in just solving crime, if you're going to be out there on secret handshake mailing lists at night instead of playing with your kids, and you're going to be out there investigating where a certain attack came from and you need access, we will just give that to you. Even if you're at a commercial company, we don't care. If you're at a commercial company protecting your own network, we don't care. We will give you access to the user interface that I'm about to demonstrate. The people who have to pay are the ones who are deriving other products on our data. So if you want to use us as a way to generate or filter or do QA or value add of some kind on a reputation feed that you're going to sell, we will sell you access to that. But the primary purpose of all of this is to make the world safer. So people who come in with that as their intent will walk out with a key in their hand. As a nonprofit, we have the responsibility of paying ourselves and keeping the doors open, which is why we don't make everything free. So here's our database that hopefully I have not lost my cookie on. This is the web interface. I will also show you a command line interface in a moment, because the web interface, hello, can I have, yeah, thank you. The web interface demos well, but I'm sure that you will not be able to imagine using it from your desk. So, Josh, what's your vanity domain? What's your company domain? ualberta.ca. Okay, so we should be able to find his NS records and other similar types of stuff. And this is not an impressive demo at this stage, because I could have done that with dig. The slight difference is dig will not tell me what used to be true. if we dip down here far enough, you'll see that, for example, his NS records are different between, oh, look at this. They're just randomly different for no reason at all. This is ugly. So from March of 2011 through now, he's been using these two. Oh, okay, and from 2010 up to March, he was using those two. So you can imagine that if Josh were a criminal, he may have taken this name server off because he ended up in a fight with some other criminal that was hosting content for him. And you might really want to know, okay, so if it changed in March of 2011, what did it change to and why? And so I can ask questions about that thing. I see. Okay. There's really nothing particularly exciting about that. But I am interested in this network. So I've already shown you that this will give you some history. It'll tell you what used to be true, rather than just telling you what's true now. But that's not the power of it. The power of it is being able to ask questions about, well, what answer was given out, and what questions could have produced this answer. So let's find out for his Class B network. Let's get rid of some of this junk. Well, this is a big result. 7,000 results. I have to tell you that we would cut this off at 10,000 because after 10,000 the browser crashes. So we limit it. If you use it in the command line mode, which is actually a web API that I'll describe, there's no limit to how much data you can get back. So what we have here is this really long list of names which have answers in his block. Now, this should have, oh, it's because I said any, darn it. Let's look for A records. I'm hoping this is going to list the address of each one rather than just the name. I am not using the public interface. Okay, I'm using a internal interface that sometimes doesn't work. Demo's better that way. So here is this borderware.org thing, IPDNS. Was using A records in Josh's IP block, but probably was not using them as host names for web browsers. If I click on one of these, I'm hoping to be able to get it to show you the IP address. All right. Yeah, there you go. That previous display is hiding these IP addresses. It would normally tell you what address was associated with each of those names. But you can probably imagine why law enforcement people love an interface like this, because if they get their hands on one IP address that was used by some child abuse materials gang, they can get from that to all of the domain names that have ever returned that. They can get a list of all the name servers for that. They can get a list of all the other domain names that have ever used that name server. Let's go back to this and let's find out what other evil Josh is performing. So looks like name.ualberta.ca is one of his two name servers of choice. Let's take a look at all right. So here we go. In the first column, you'll see a domain name. Second column tells you the type, and the third column tells you that the value is equal to my search key. So these are all of the domain names that have used this name server as their publication point. And in his case, he's not a criminal, although I would say beartracks.ualberta.ca is suspect. But look at all these other cool things, udigitsystems.ca. This is evidently a spin-out. Some professor decided that he'd rather have an IPO than a retirement benefit. ualberta.biz. Not sure we had any other easy way to find out that they thought that they were taking .biz seriously. This kind of permuted index work, where you can find out all of the related properties from a domain, is, it is a game changer. If you are chasing bad guys and they think that whois privacy is going to save them, I had one fellow inside of the FBI's Child Crimes Division tell me, without being willing to tell me the details, of course, but he said, yeah, I went out 2 degrees of separation from the one IP address I had, and I looked at all of the history of all of the different domain names and name servers and IP addresses, and I found one thing that was 36 months old that was clearly owned by the same person, and which the criminal had thought was so far separated in time and so far separated in data relationships that it did not need whois privacy. And we arrested him. Thank you very much. And I thought, okay, there was a point to this. So, very briefly, I see I'm down to my last 12 minutes by that clock, but I think that clock may have started late. I'm down to my last minute if you guys wanted to make the next talk. Oh, good. I apologize for the fact that this is Windows. I have a job that calls for me to be able to read Microsoft Doc and DocX files. And when I tried to buy a Macintosh, they tried to give me a chiclet keyboard. So this is a tiny little shell script that calls curl, C-U-R-L. It is going to transmit my question as a RESTful query. It is going to receive an answer that is in JSON format, and it's going to trivially format that result for me. So let's start with the query. I'm picking on Josh. I may as well pick on Jose, although he doesn't work there anymore. Oop, all went by in a hurry. So you can see they changed their delegation in .NET. We download the .NET file, so any place you see that it's never been accessed, count as 0. That means that's a zone file import that we did. And you can tell that from February of 2011 till March of 2012, they have been using 5 name servers. And before that, they were using 3. Okay, well, makes a certain amount of sense. Where you see the bailiwick of .NET, but the count is not 0. That means it's not a zone file, but that is a response that came from one of the known authority servers for .NET. We kind of have to guess what the bailiwick was in that case, because we're not inside the name server. We don't know where they thought they were, but it's a reasonable guess. Let's take a look. Let's do a similar type of query, because I really am out of time. And I want to get to the juicy ending here. If I want to search the R data, and I'm interested in that, NS, no, that's not it. Name, sorry. Right, so here's all of the different domain names. Peak flow, you see quite a lot of peak flow here. That is one of Arbor's fairly well-known boxes. It is pretty much the Cadillac of NetFlow processing devices. If you want to do NetFlow and you're looking for something to do it with, that would be my choice and my recommendation. myarbor.org, looks like they've got a portal. Arbor Pravale, I don't even know. But I can certainly find out a list of all of their brands, in this case, all of their networks. Not that Arbor's got anything to hide, but you could imagine that a criminal might not like to be naked in this way. So let me tell you the implications of this. If you come along down my street with a camera and you take a picture of the front of my house, you have not violated my privacy. If you're the Google van and you take pictures of every house in my whole neighborhood and you make an indexed database of these accessible to anyone in the world so that anybody can see what my front yard looks like, that starts to make me feel a little bit squeamish. And I feel like I may deserve some privacy at scale that I would not ask for one by one. And that difference in how I feel is the difference between being able to find out what's true now by asking questions versus to find out what has ever been true by looking at reverse indexed questions. Again, this has been a game changer. I thank Florian Weimar for sort of raising the visibility of this. I think that we have taken it to the next level. If you would like access to this, either commercial access to this API or just nonprofit do-gooder access because you like to chase crime and this can help you, drop me an email. I'll talk it over. In fact, don't drop me an email. Go to dnsdb.isc.org and apply for a login there. And when it asks you what is your proposed area of research, if you say investigating malware, that creates more work for me because then I have to ask you what you mean. So please be detailed about that. Please operate sensors. Send us your data. If you are in the business of processing data, please consider buying a port from us or renting a port from us and getting access to the real-time data that backs this and other similar data. So we're at the end of the hour. John has a question. I just said use dnsdb.isc.org. Just visit that website. Oh, it's HTTPS.
Oh, okay.
Yeah. My email is fairly widely known. I am paul@redbarn.org.
What?
paul@redbarn.org. Or Vixie, my last name, at isc.org. Given that 100,000 other people find that email every day, I think you should have no trouble locating me online.
So that would be the HTTPS then, right? DNS.
Are you doing anything with like whois data? Because you just like mentioned, and in terms of like cross correlation, I think whois would be like more interesting actually. Like
we don't currently have whois because there are a couple of other entities out there like superwhois.net or .org, which is Rodney Jaffe's thing. There are some people who aggregate and cache whois. And in order to make that work, you have to make a deal with every domain whois provider because everybody has to rate limit at this point. We've decided that that is a solved problem. The thing I'm trying to do is to get starting with the RARs, and I am a member of the board of trustees for AARON, so that would be an RAR that I might have an in with, but also RIPE, APNIC, et cetera. I would like to get the query stream. I would like to get all the whois queries that they receive because most bots now, when they start up, do a whois query on their own IP address in order to find out how safe it would be to relay spam from here. And so these RARs are getting bursts of like millions of whois queries per hour when a new botnet starts up. And I think that data would be very interesting if I could share it with all of you. So we are working on a whois channel for the queries, strangely enough, rather than the responses.
so more or less like passive sensor to grab the whois requests. But with the whois thing, there is no fixed format, and it's basically like kind of worms in terms of like parsing and.
That would be the other problem. If you were going to try and do a permuted index on whois, similar to what I've described for DNS, you would find that you had to do a lot of free text parsing, which is extremely expensive and unreliable. There is always a WHOIS working group. For the 20 years I've been involved in IETF, we never go more than 2 years without an internet draft proposing a unified format for WHOIS. So no matter what time you decide that you'd like to go help with that, there will be somebody trying to reinvent WHOIS. So I recommend getting involved. We are seriously past 10 o'clock here, so.
Okay, thank you, Paul. Now we have a coffee break, and we'll be back at 10:30.